Hi everyone, hope everyone is okay. Welcome to the Mr. X free class for grade 11s. We are under the topic Surds and it's going to be an exciting time. Please do note that this topic is applicable to grade 11s and also very importantly applicable to grade 12. So welcome. But very importantly, I also want to make sure that you understand what's going on. I'm so excited about what's happening from the 3rd of February 2025. So I will be hosting for the whole year extra classes, online classes for both grade 11s and grade 12s. These classes will be happening from 7 p.m. to 9 p.m. In fact, every single subject that's maths and physics that I teach will be done once a week. For an example, for grade 11s, maths will be on Mondays. Right? Every Monday, maths, that's from 7 p.m. to 9 p.m. Then physical sciences on Wednesday, 7 p.m. to 9 p.m. I'm going to have 5 classes or 5 lessons per month. That amounts to 250 per month per subject. So if you want to do one subject, 250. If you want to do 2 subjects, it's going to be 500 rands. Each class is recorded live and given also to those that paid for it in case they want to watch it again. But it's going to be an exciting time. The structure is similar to what we're having right now, where we are learning and preparing. For most of you, you have seen the comments, the testimonies from students that I taught last year and the year before or the other years, whom I have made to get distinctions in mathematics and physical sciences. And I'll tell you the secret, they attended these classes. It was a beautiful time that we had in 2025. I'm making sure that we're going to win together on that one. All right, having said that and put that on the side, let's get down to the business of the day. What are we doing? Surds. Surds the topic. Let's begin on that one. Now, in mathematics, when you speak about a surd, you are saying to yourself, a surd is the root of a whole number that produces an irrational number. What do you mean, say? So you see, you've got a root that's part of the definition. And then there is a whole number inside the root, but it produces an irrational number. What we mean is, in other words, a surd is a root of a number that cannot be determined exactly. For an example, root of 2, when you put it in the calculator, is not really a straight number. It gives you 1.4142, so forth and so on. So the surd is the root of a number that cannot be determined exactly. There are other examples. Root of 5 as well, that's a surd. It's not as easy to determine the number exactly. But if you think about it, root of 25 is not a surd because root of 25 gives you a straight number 5. In the same breath, if you think about cube root of 64, it's a straight number that it gives you, and so therefore it cannot be a surd. If you cannot determine it exactly, it's a surd. And if you think about it, these are the examples that I gave, and these ones are surds, but these ones are not surds from there on. It's important, therefore, when dealing with mathematics, to know how to answer questions and use the rules that come with surds. So here are the laws of surds. So I'll show you, then we can do some many different questions to help us to understand this. Here's something. It says to me, there's n, then root of x multiplied by n, then root of y. Looks like there's something similar. There's an n for n right there. And the law eventually says it is n root of x times y. Look at this example. Root of 5 is a surd, multiplied by root of 3, also a surd. Now, there is a ghost 2. Every time you write the square root sign, let's say you say square root of 5, there's a ghost 2 that is there. We don't put it, but it's always there, a ghost 2. So in this case, they've got the same ghost. It's a 2 there, it's a 2 there, it's an N there, it's an N there. And the law says to me, if the ghost is the same, then they are multiplying, it's as good as saying root of 3 times 5, root of 15. Similarly, look at root of 20. You see, root of 20 can be broken down into anything. Can be broken down into 4 times 5. But 4 is interesting because 4 under a square root will give you 2. So look at it, the root of 4 times 5 is broken down into root of 4 times root of 5, but root of 4 will give you the answer 2. If you were to put this in the calculator and say root of 20, your final answer is actually 2 root of 5. So in the laws of surds, when there is multiplication and the ghosts are the same, you just multiply the inside numbers, the numbers inside the square root. Show us, say, if I say to you, root of 8 multiplied by root of 3, it's as good as saying root of 8 times 3 eventually is going to be root of 24. Basically, that is the law of multiplication of surds. The ghost must be the same. If it was a 3 here, the ghost 3 there, the ghost 3 there, and eventually again, the ghost 3 there. Now, in multiplication, work with me. In multiplication, this is what we do. But in division, it's almost the same thing. The ghost is n, the ghost is n. There's an a under the square root. There's a b under the square root. It's as good as saying the ghost n, a over b. Look at this example. The ghost 3. The ghost 3. There's root of 16 at the top. There's root of 2 at the bottom. It can be written as the ghost root of 16 over 2. And 16 over 2 is 8, by the way. Then cube root. Since the ghost is 3, cube root of 8 is 2. So these are the laws of exponents for both multiplication and division. Let's do some practice questions on this one here. Work with me. I'm with you. Examples. I hope you guys have your books by the side and we're good to go. So examples, we're going to evaluate these particular questions and come up with answers to them. So I'll do a couple. I'll give you some to try on your own. We work it out together. I'm going to do number 1, 2, 3, and 4. Then I'll give you to do 5, 6, and 7. So let me do 1 to 4. Let me know when there's questions. Work with me. Work with me. So in the exam, what they ask is evaluate this without using a calculator. Now, don't be Chuck Norris and be clever for nothing, Chuck Norris. Ne? Don't be. Because if you become Chuck Norris and you use a calculator, you're going to get a beautiful 0 because they will know the answer is very direct. You must show steps for you to be able to get your full marks. Start again. Root of 7. Now, zo times root of 3. Okay. This can be written as root of 7 times 3, the multiplication law, which is root of 21. So that's number 1, done and dusted. Let me know where there's a problem. Then there is 2 root of 3 squared. 2 root of 3 squared. Let me explain. Listen to me. You see, in maths, if I say to you x, let me do this. Let me say x, then I say squared. It's as good as saying x is multiplying itself twice. The same idea comes here on this question. So I'm saying 2 root of 3 squared. It's like saying 2 root of 3 multiplied by 2 root of 3. And when you say 2 root of 3 times 2 root of 3, the 2's multiply. So it's 2 times 2, which gives you 4. Then also the root of 3 multiplies the root of 3, and eventually your answer is 3. So now it's 4 times 3, which gives you a value of 12. That's how you do it. If you don't want, this is how you can do the shortcut. Follow my lead, I got your back. So it's 2 root of 3 squared. Quickly, just say 2 squared. It gives you 4. Then say root of 3 squared. It gives you 3. This is a very important rule to understand that when you say root of 3 times root of 3, you get the answer 3. So in other words, in maths, root of x times root of x, at the end of the day, your answer is x. That is the rule that we work with here. So 2 root of 3 squared is 4 times 3. The shortcut of it would give you the answer of 12. That's number 2 right there. Talk to me. Are we still together? Let me know. Give me some feedback onto all of this so that we can understand what we are doing. We'll make sure that we win on this one. You can write this on the side and we work together. Let's go to number 3. Very interesting now. So when I taught you the laws, I say to you, there's a multiplication law, then there's a division law. I never spoke about the addition, neither did I speak about the subtraction law. Let me explain to you via a question so it becomes easier to understand. Let me show you basics. In basic mathematics, basics, if I say to you 3x minus x plus 7x, very easy to do. 3x minus x plus 7x. What's the answer? Talk to me. You get what? I think you should get an answer of 9x, isn't it? When you do the maths together there, right there. So very important that you get that. So that's just basically the same things. Now look at this question, question number 3. Look at this. It says 3, okay, root of 6, I see you, minus root of 6, I see you, plus 7 root of 6. This root of 6 business seems to be quite popular. So in other words, think about it. The root of 6. Think about it the same way you thought about abo x. The same way. 3 root of 6, 3x, minus root of 6 minus x, plus 7 root of 6, 7x. Think about it because it's the common aspect in all of this. So therefore your answer becomes 9 root of 6. That becomes your answer at the end of the day. So please remember this. When it comes to addition, look for the common one. Look for the common principle. It is applicable in all aspects. 3 root of 6 minus root of 6 plus 7 root of 6. Eventually, you're going to get your answer in that aspect right there. All right. Let me work on it and we pull through together from there on. All right. Let's try. I want you guys to try number 4, 5, 6, and 7 very quickly. 4, 5, 6, and 7. I'm going to give you 5 minutes to do that. Work on it. 4, 5, 6, and 7. 5 minutes. It's up on you. Let's do this, Chuck Norris. Let's do this. Right, we should be done. Let's try and work it out together and see how we can do it. Don't worry, when you have questions, you can always ask. Let's do number 4. So number 4 is quite exciting because again, ghost 4, ghost 4, ghost 4. But it looks like to me there's a root of 3 everywhere. Again, a root of 3. The same way we dealt with our x. So this thing will end up like as good as saying, imagine if it was x plus 7x plus 5x, it will end up as 13x. So your answer for this one is 13, the root 4, or that is the 4, and then the root 3 there. That becomes the answer. Did you guys get this? Talk to me. Did you get this? Talk to me. Yes, you get 13. Beautiful, beautiful. All right, let's try 5, 6, and 7. I see people saying on the chat today, you say, we are so confused. Aibo, don't worry, Ndwana, I got your back. Listen to me very carefully. So the key is finding common ground. That's the key. Find common ground. You see, in mathematics, everything is relatable. You must look for a way of being able to find common ground. Let's break down some maths. I've got 2 root of 18, okay, minus root of 32. What common ground can I eventually have? I can write this as 2. See, 18 can be written as 2 times 9. You can write it like that if you want. 18 can be 2 times 9. Or if you want in essence there's so many ways you can do it. So it's going to be 2 times 9 minus here, the 32 can be 2 times 16. Now, earlier on, I said, when it's like this, root of 2 times 9, it can be written as root of 2 times root of 9. Same here, can be written as root of 2 times root of 16. Work with me. The root of 9 is actually 3, right? There's still that 2 and that root of 2. Common ground, root of 2. Common ground, root of 2. Minus root of 2, root of 16 is 4. Go back with me. I needed to find common ground. I needed to find a way to relate 18, not 32. Then I noticed that if I say 2 times 9, 9, because it's a perfect square, can be changed to 3 when you root it. 16, perfect square, changed to 4 when you root it. So that was the key, and there's a root of 2 there and another root of 2. So in maths, then we'll say 2 times 3, this can multiply easily, 6 root of 2, minus root of 2 times 4. Always put the number in front and the root after. Number in front, root after. And now look at this. Common ground. Root of 2, 6 root of 2, minus 4 root of 2. 6x minus 4x, the answer is 2 root of 2. And that's question number 5. Talk to me. Talk to me. Get it? Yes or no? That's number 5. Always look for the common ground. Always look for the common ground. Work with me. Perfect. So the idea in everything, just to repeat this so that people can understand, when dealing with surds like this, make sure you find a common ground. So it's root of 18 and then there's root of 32. 18, 2 times 9. Why did I use 2 times 9? Because I knew that 9 could easily be rooted to become a 3. Why did I say 2 times 16? Because I knew that 16 could easily be rooted to become a 4. Then there's the root of 2, which is a surd. And then eventually, root of 9 is 3, 2 times 3, 6 root of 2. I say to you, make sure the number, Chuck Norris, the number is always in front. 6 root of 2. Here it was root of 2 times 4. The number in front, 4 root of 2, common ground, 6x minus 4x, 6 root of 2 minus 4 root of 2. Answer is 2 root of 2. Let's go over number 6. Quickly, let's go for number 6 right there so that people can understand. Work with me without a calculator. Root of 32 over 2. Common ground. You see, you can always write, if it's possible, let me give you a heads up. When you get a number, if it's possible that you can break the number, and when you break that number, one of the numbers can be rooted easily, then please do so. What are you saying, say? I'm saying 2 times 16. Why did I choose that? Because 16 can be changed backwards or given out nicely into a 4 under a square root. That's why I was able to break 32 into 2 times 16, which eventually becomes root of 2 times root of 16 over 2. Don't be Chuck Norris. Chuck Norris says 2 into 2. Kanjani, bro. Kanjani. This one at the top is a surd. It can't. You can't just divide like that. Change the root of 16. It gives you root of 2 times 4 over 2. Then you can do the magic. The 2 gets into that one, which is common. There's the 2. Your answer becomes root of 2 times 2. But what did say? The number in front, 2 root of 2. That becomes your answer in that particular stance. That's number 6. Guys, get it? Talk to me. I want to go to number 7. Number 7. Always ask questions and we take it up from there. Always ask questions. I repeat what I say, so let me go through this one more time very quickly. Root of 32 over 2. Look for something that you can manipulate. Can I change 32 into something that I can manipulate? The answer is yes. What can I do? 2 times 16. 16 is key for me because when I say root of 2 times 16, it ends up as root of 2 times root of 16. The root of 16 can quickly be changed into a 4. Now I've got root of 2 times 4 over 2. Then the 2 will get into the 4, leaves a 2. 2 times root of 2. That becomes eventually your answer at its very best. All right, perfect. That's just what you do for number 6. Let's try number 7 quickly and we'll move through together. Says to me on number 7, like I say to you, always look for common ground. It's root of 8 plus root of 2, all this over root of 2. So here's where the problem is. Basics of maths are very important. If I say to you in maths 3 plus 6 over 2, you can't say this. You can't say this. You can't say this and say, it's 3. So the answer is 3 plus 3, which is 9. That's what you can't say. You can't say that. All right? The key for me is understanding this. You've got to know that this denominator, U2, affects both U3 at the top and 6 at the top. So this denominator is not just for this guy, U root of 8 or U root of 2, but for both of them. In fact, this is as good as writing root of 8 over root of 2 plus root of 2 over root of 2. This is very important. So at the top there, I've got root of 8 plus root of 2 over root of 2. Common ground. What can I do? Work with me. 4 times 2, I've changed 8, plus root of 2 over root of 2. Then 4 times 2. Remember, I can always square root 4 and it will give me a 2 and it goes outside. Remember, the number goes outside. So now I've got 2 root of 2 plus root of 2 over root of 2. That's what I have. You see, the 2 comes from the root of 4. Then this one is inside, still remaining as root of 2. Then, now things are common. 2 root of 2 plus root of 2. 2x plus x, what you get? 3x. 3 root of 2 over root of 2. Then eventually they will cancel out. Gone, gone. And your final answer for number 7 is actually 3. So that becomes your answer on that one. So very important that you get that and we take it up from there. So it's always about the common ground. Get the common ground. That's the key. Once you get the common ground, you're done with everything and you're good to go from there on. Let me repeat this one more time. Follow my lead. Look at this. So I'm saying to you, there's root of 8 and root of 2 over root of 2. Please do not be Chuck Norris, okay? Do not be Chuck Norris. Don't cancel. Na boy, what are you doing? When's that? Don't cancel because this root of 2, this denominator affects both root of 8 and root of 2. Remember that. That's why I said it's as good as writing it like this. And then now that we're here, common ground, let's see what we can do. I noticed that I can rewrite 8 as 4 times 2. I can. And so it's now root of 4 times 2. But inside this square root, 4 can be rooted to give me 2. So now that 4 rooted to give me 2, the number goes outside. Then I still have this 2 that remains inside here. 2 root of 2 plus root of 2 over root of 2. And so now there's common ground. 2 root of 2 plus root of 2, which gives you 3 root of 2 over root of 2. Then the root of 2 eventually cancels out. And all I am left with is the number 3 right there. All right, so that's very important that you get that right. Somebody has a hand. I'm ready to unmute. Go ahead, ask your question.
So, the part that says root 8 over root 2 plus root 2 over root 2, does it make sense mathematically to cancel out the root 2 over 2 and be left with root 8 over root 2? Then, since you have the same thing is roots, I guess, you make it one big root 8 over 2. Yes.
So
you
like
make it
this.
one big.
Okay, let me see this. So you've cancelled out. This is 1, right?
Yes. And then you make that one big root because it's the same thing.
Like
8 over 2.
Like this.
No. You know that law where you said if it's that you have n.
Oh yes, like this.
Outside.
Yes, like this.
Yes.
So then this becomes root of 8 over 2 is 4 plus 1. Then root of 4 is 2. 2 plus 1 gives you 3. Still get the same.
Yes.
Perfect.
Oh, okay. Will I get penalized or
No.
some?
You won't.
Okay.
You'll get full marks. There's so many ways of doing this. You can even factorize this part. There's a part where you can actually factorize if you want. I'll show it to you on a later basis. But basically, there's so many ways. And I just want to allude to this fact. Guys, there's so many ways of doing a question. So many different ways. So this was part of them and I wanted to show you. And thank you so much for that one. let's try and simplify and do some questions together here, but it becomes easier to work it out there. I hope people are getting this and pulling through. All right, let's try and get to some more difficult questions together just to see if we're going to win and take it up from there. All right, somebody has a hand. Go ahead, I'm listening. I've unmuted you. Please say something. All right, I'm not winning in that aspect. Oh, yes, yes, please.
So we've already passed, but like I had a question.
You mean this question here? There it is.
Yes. So, sir, for the root of 8, yeah? So can't we like simplify 8 and say since 8 is a 16 and say 2?
Okay, I can't hear you. Sorry,
2,
can you get closer to the mic? I can't hear you. You're saying for the root of 8, what do we do?
Okay. So can't we like say 2 to the power 3, like since it's a perfect cube?
Yeah, you can say 2 to the power 3, but it won't help you much because eventually you're still going to get back to the same place. So even if you say 2 to the power 3, this is still a ghost 2. It's not a cube root of just a square root. So it won't really help you much. You can get the answer right eventually, but you need to do a longer process for you to do that. So in maths, the key, that's why I said, you see why I knew I needed to make 4 times 2 is because I knew that 4 can change into 2. And once I have that, there is now a root of 2 here. And I also have this one. Now I have common ground. That's why I needed that. Yes, you can do this. You need to now actually solve it using AMA laws of exponents eventually. But otherwise, the easier route is always this. In maths, always try your best to get the easiest and the fastest route possible. Is that okay now? All right, perfect. All right, thank you so much. Let's try and do some questions together, fam. Let's try and do some questions. Let's go for some practice exercise. And then I'll show you rationalizing the denominator and so forth. And then the question says, simplify the following without the use of a calculator. Simplify the following without the use of a calculator. Now, you've got number 1 or A, which says to me, root of 80 plus root of 45 all over root of 125. Common ground, common ground. You see, the times table that we learned in grade 5, 6, 7, what times what, comes handy here. Very much so. Common ground. You see, it's very possible that you could make this common ground. Look at what I'm going to do. Root of 80 can be written as 16 times 5. 16 can change into 4, right? Yes. Root of 45 can be written as 9 times 5. Root of 9 is 3, right there. At the bottom there, the denominator, root of 125 can be written as 25 times 5, and I can change this 25. All right, look at this. The root of 16 becomes 4, so now it's 4 root of 5, plus the root of 9 becomes 3 root of 5. Root of 5 is common ground. The root of 25 becomes 5 root of 5. And so now almost done. Look at this. Common ground, root of 5 root of 5. 4x plus 3x. 4 root of 5 plus 3 root of 5. 7 root of 5 over 5 root of 5. And eventually the root of 5's cancel out, gone, gone. And your answer is now a number 7 over 5 without using a calculator. That's A. Please write this one down. Let's try B right there. I need to sort out something with B. Let me make this into a minus. I think there was a mistake there for B. All right, please write this one down just so that we can get to understand where we are coming from. Let's try the next one, B, together. B. So in B, I'll write it as root of 8 minus root of 2, all this over root of 50. That's how I'm going to write it. Root of 8 over minus root of 2, all this over root of 50. All right, perfect. Let's see what we can do. The key is understanding. I want to do the first 3 questions, then you're going to do D and E. Ooh, D and E, very exciting, very interesting. Key. What is the key? Common ground. What is the key? Common ground. Say it after me. Common ground. Samba, smangena, boy. Root of 8. Common ground. 4 times 2 minus root of 2 over 50. Common ground. 25 times 2. We do the maths. Root of 4, remember the key, right? Root of 4 can be broken down easily. So root of 4 is actually going to be 2. Now we got 2 root of 2 minus root of 2 over here. 25 is 5 when you root it, root of 2. At the top, 2 root of 2 minus root of 2. 2x minus x is x. 2 root of 2 minus root of 2 is root of 2 over 5 root of 2. And eventually our root of 2 cancel out, gone. At the top now you got a 1. So your answer is now 1 over 5. That becomes your answer, 1 over 5. Always find common ground. Hear my voice in the exam, hear my voice in class tomorrow. Common ground. Always find common ground. And I always repeat what I say, guys. I always repeat what I say over and over again until you understand, okay? So the idea is root of 8. Change it. Common ground, root of 2, 4 times 2, which changes the 4 into a 2, 2 root of 2, minus root of 2, 25, right? Remember it was 15, eh? 25 times 2, 5 root of 2, and then eventually 2 root of 2 minus root of 2 is like saying 2x minus x is equal to x. It's like saying 2 root of 2 minus 2 root of 2, minus root of 2 rather, is root of 2. They cancel out. There's a 1 at the top, 1 over 5 right there. So you can leave the answer as a fraction because it's 1 over 5. 1 over 5. Let's try C. Let's try C very quickly right there. If there's questions, let me know. I love your comments. Thank you so much. Remember, this thing is being recorded, ne? Remember, you can always watch this on YouTube anytime. You can always watch this on YouTube anytime. Thank you for the beautiful comments. Mr. X makes maths easy and we're cooking, Baba. We're doing this. We're winning. Fire on fire. Common ground. Cash contant. Nka. Ah. Shanda pa. Azo. Maradona lo. Asambu C. Asambu C. Spange. Let's go for C. Let's get excited and learn while having fun. C is interesting because now there's brackets involved. There's brackets involved. All right. Let's see if we're going to work it out. So it's 5 plus root of 2 brackets marung tuana. Now, so there we are. So it's 5 plus root of 2 minus 5 multiplied by 5 minus root of 2. So in essence, it's basically the same way that you would do if you were to multiply things in a brackets. Look at it this way. If I say to you x plus y bracket x minus y, right? You would say x times x, which is x squared. You would say x times negative y, which is negative xy. You'd say here positive y times x, which is positive xy, and eventually positive y times negative y squared. That's what you'd say. Same idea here. Let's do the math. Let's go together. It's a 5 times 5. I think I get 25. It's a 5 times negative root of 2. It becomes negative 5 root of 2. Okay? It's like saying 5 times negative root of 2 is definitely negative 5 root of 2. Here, positive root of 2 times 5 is positive 5 root of 2. Then eventually, root of 2 times negative root of 2. Let me write it on the side here to make it make sense. So it's root of 2 times negative root of 2. It becomes negative 2. Yep, negative 2. Remember what I said earlier, Uti, when the ghosts are the same, the numbers the same, the root cancel, you're left with 2, but because there's a negative, it's now negative 2. So therefore here, where we've got root of 2 times negative root of 2, the answer is negative 2. Notice something. These are like terms. Negative 5 root of 2 plus 5 root of 2, the answer is 0. So now you've got 25 here. This eventually gives you 0, minus 2, and your final answer without a calculator is going to be 23. That's very important that you put that through. It's going to be 23. Somebody's asking, can we put this in the calculator? If you do so, you get 0. Also read the instruction without Chuck Norris, without a calculator. You put this in the calculator, you move from there to there, you get 0. A beautiful, demure, QT, mindful 0 right there. So very important that you get this right. I want you to try D and E. D and E. Let me give you about 3 minutes. D and E. Get down to business. Right here, right now. I got your back. 3, D and E. 3 minutes. I'm getting a boy. All right. I think we should be done. Let's try this together. And while learning, don't worry. Making mistakes is part of learning, okay? Making mistakes is part of learning. Somebody has a hand. Let me just attend to that. Go ahead. I'm listening. You have been unmuted. I can't hear you. Maybe you can just type your message and we take it up from there. Let me try D quickly. D. So D says 3 root of 2 plus 2 squared. Notice that every time you say squared is the same expression. Oh, yeah, I can hear you now. Go ahead.
Oh, I was testing.
Okay. All right. So we're good now. 3 root of 2 plus 2 multiplied by 3 root of 2 plus 2. And we work it out from there. Let's go. 3 root of 2 times 3 root of 2. If we do it on the side here, it's like saying 3 root of 2 times 3 root of 2. Remember the roots of, ne? About root of. They will eventually cancel out. And so now this is like 3 times 3, 9. Root of 2 times 2 is 2. So this is like 9 multiplied by 2. Then we go further. 3 root of 2 times 2. So let me write it here. 3 root of 2 times 2. So the numbers multiply. 3 times 2, that gives me a 6. So that's plus 6 root of 2. Same thing, we're foiling the FOIL method. 2 times 3 root of 2 is the same answer. 6 here, root of 2. Then eventually, 2 times 2, it gives me the number 4. 9 times 2, that's 18. Common ground, common ground. These guys are the same. They are like terms. That's the terminology in maths. Like terms. 6 root of 2 plus 6 root of 2 is 12 root of 2, eventually plus 4. Bring the numbers together. I see 22 plus 12 root of 2. And eventually your answer ends up in this aspect. So 22 plus 12 root of 2. Let's try E. Hope you guys got it and you are okay in that aspect. The FOIL method, guys, the FOIL method. One more time, let's do the FOIL method. I need 3 root of 2 plus 2 squared means 3 root of 2 plus 2 multiplied by 3 root of 2 plus 2. 3 root of 2 times 3 root of 2. I gave the example here. The numbers multiply 3 times 3. I get 9. Root of 2 times root of 2 is 2. So it becomes 9 times 2, which eventually gave us 18. Then again, the FOIL method. Remember, we started off here. Then we go to that part. Then 3 root of 2 times 2. This is the part here. 3 root of 2 times 2. The numbers multiplied 3 times 2. That's 6 root of 2. FOIL again. Here we are. 6 root of 2. 2 times 2 is 4. Like terms together, your final answer is what you see there. That's E. That's D rather. Let's try E, which looks a bit more interesting and a bit more all over the place. Interesting one together. Let's go, go, go. Let me see. I hope you guys got this right. All right. Work it out, work it out. Just try E. E is a bit more interesting. Oh, my word. E. Talk to me. So E says to me, 2 over root of 3 plus 1. Nazo. Then you've got root of 3 over 2 minus 1. Let's FOIL this thing. Let's FOIL. Let's go. Nazo. 2 root of 3 times root of 3 over 2. Let's do it on the side here. So 2 over root of 3 multiplied by root of 3 over 2. In maths, this is not too bad. Very doable if you think about it, because this root of 3 will cancel that root of 3. Then the 2 cancels the 2, and your answer is 1. There, 1. So when you FOIL this, when you say this times that, it ends up like that. Then 2 root of 3 times negative 1. So it's like 2 over root of 3 multiplied by negative 1. Well, shouldn't be that difficult. It's negative 2 over root of 3. So I'm here, negative 2 over root of 3. Then we FOIL again. We're here now. Plus 1 times root of 3 over 2 is a plus root of 3 over 2. Then here, plus 1 times minus 1 is negative 1. So this is where I am currently. Do the maths. 1 minus 1 gives you 0. And now I'm left with negative root 2 over root of 3 plus root of 3 over 2. Now, before I go further, let me show you some basic maths. If you were to ask me what the most important topic in maths is, I'll tell you, algebra. We'll use algebra now. We'll use it in every topic. In trigonometry, it's worse. What I'm showing you is what we do even in trigonometry. Right, work with me. Let me start with basics. If I say to you, 2 over 3 plus, let's say, 5 over 4. The common denominator is 12. And it's, yes, 3 times 4, 12. Then once you get the common denominator, listen to me, Chuck Norris. Once you get the common denominator, cross multiply. Once you get the common denominator, cross multiply. 2 times 4, 8. Plus 3 times 5, 15. And here the answer becomes 23 over 12. I'm showing you a simple method of dealing with fractions. What's the common denominator? 3 times 4, 12 yellow. Sharp. What is saying? Once you get the common denominator, cross multiply. Once you get the common denominator, cross multiply. Let's take what we've learned here and put it here. Negative 2 over root of 3 plus root of 3 over 2. Sharp. What's the common denominator? The combination of root of 3 times 2. Just like here, it was 3 times 4, which gave me 12. Here, root of 3 times 2, which is like 2 root of 3. And what did say? Once you get the common denominator, cross multiply. Work with me. Negative 2 times 2, negative 4. Root of 3 times positive 3 times root of 3 is positive 3. I need the root of 3 times another root of 3 gives you a 3, the same thing. Then eventually your final answer, negative 4 plus 1 is negative 1 over 2 root of 3. And that's your final answer. So if you used a calculator, you'd move all the way from here to this answer and you'll get 0. In maths, the steps matter. One by one. The steps matter. One by one. And that becomes your answer. Negative 1 over 2 root of 3. Let me check some of your questions here just to see if we're winning. Can't we transport the 2 to the top? The 2 to the top. I'm not understanding. Maybe you can unmute yourself and try and explain further so that I can understand and be able to answer appropriately to help each other out, right? So this is very important. The basics for everything. I tell you this now in the beginning of 2025. The bulk of the maths that you're going to write in grade 12 is what you learn in grade 11. The basics are everything. Get the basics right and you're done with everything. All right, I'm taking this out. Gone, gone, going. All right. Somebody says, I can't unmute myself. Just raise your hand and I can be able to answer your question. All right. I'm taking this out now. It's gone. Let me talk about the next concept, which is known as rationalizing the denominator. Rationalizing the particular denominator. But before that, let me answer some of the questions that are coming through. All right. Go ahead. I'm listening. Make sure that you're close to your speaker because some of your words are muffled.
Oh, Minye, I'm trying to understand here. You see the final answer is -1/2 square root 3. So I'm asking that, can we take the 2 and add it or minus it with the -1 on top?
We take the 2 and put it at the top.
Yeah.
Why? We can't do that. So like saying 2 at the top. No, we can't because they're not common and they're not even canceling each other out. So you can't really do that. The best you can do, you do this in grade 12 though, is saying -1/2 times 1/√3. That's the best you can do. Otherwise, there's not much you can do. This is why this is your final answer. Yeah.
Oh,
all right, man. All right.
Point, yeah, done.
Okay, you're saying?
If you reach this point, like
you're done. Yes. You'll be done when you get there. That'll be your final answer. This is the simplest you can express it as.
Okay, thank you, sir.
Anytime, my man. All right, perfect. So that's where you have it at the end of the day, -1/2√3. All right, I'm about to take this out and we take it up from there. Okay, other people are asking me to repeat. It's fine. Let me go through this one more time so that it's easier. Let me see what I can take out just to illustrate my point. Then we go to rationalizing the denominator. Then we go to Surds equations, which is very important for grade 11s and grade 12. Guys, FOIL. The brackets, open them. Open the brackets. Open the brackets. So 2√3 times, I need to FOIL this one first. 2√3 times √3/2. There. 2/√3 times √3/2. Because they are multiplying, canceling becomes easy. So there you are. Eventually the answer is 1. Yeah? 1. Then 2/√3 times -1 will give you -2√3. Then +1 times √3/2 will give you this +√3/2. Then +1 times -1 is -1. Now 1 minus 1 gives you 0. That's why it's gone. So now I'm left with the fractions like this. And then I said something very important that I need you to remember. Using this example of 2/3 plus 5/4. When dealing with fractions and you are adding, even if you're subtracting, the common denominator is very important. And so 3 times 4, 12. And I said, once you get the common denominator, cross multiply. 4 multiplies 2 gives you 8. 3 multiplies 15 gives you, 3 multiplies 5 gives you 15. 8 plus 15, 23/12, eventually. And I'm doing the same thing here. Same thing. What's the common denominator? √3 times 2, which is like 2√3. I told you the number goes in front. Then cross multiply. -2 times 2, -2, -4. Cross multiply. √3 times +√3, +3. -4 plus 3, -1/2√3. That becomes your final answer at the end of the day. All right. At the end of the day. I'm good on that. Let me go to the next one. Work with me. Look at this. Let's talk about the concept of rationalizing the denominator. Rationalizing the denominator. Let me teach you very quickly. You will understand this perfectly. So when you're dealing with surds, simple surds for that matter, when we simplify, sometimes we can leave the denominator as a surd. You can leave the denominator as a surd. Like, for example, the previous question that we did, we left the denominator as a surd. Remember, the answer was -1 over 2 root of 3. You can do that. But I want you to understand that the calculator does not do that. The calculator actually rationalizes the answer. Rationalizing means that the answer will not have a surd as the denominator. So when the calculator rationalizes, there is no surd in the denominator. Look at this. Root of 3 over root of 2. I need to the denominator has a surd there. So it's root of 3, all right, over root of 2 right there. When you put this in the calculator, root of 3 over root of 2, the answer is now root of 6 over 2. Notice that this 2 is not a surd. The denominator is not a surd. The calculator rationalizes. But how does it do that? What happens when you're rationalizing? Let me show you the same example. Root of 3 over root of 2. And they say rationalize. To rationalize means to ensure that at the end of the day, the denominator is not a surd. So how can we do that? How can we do that? Let me show you basics. If I say to you 2, if I wrote the number 2, it's as good as saying 2 times 1, right? If I say 3, it's as good as saying 3 times 1. I can do that. And so look at this. Root of 3 over 2 can be written as root of 3 over 2 times, you see the denominator, root of 2 over root of 2. Ooh, root of 2 over root of 2, yeah, because root of 2 over root of 2 is 1. And so you manipulate maths. You say, I don't want to have this at the bottom. I don't want to have it as a surd. So let me multiply by root of 2 over 2. The very thing at the bottom, but root of 2 over 2 over root of 2. Because root of 2 over root of 2 is like saying times 1. Okay? Therefore now we can do the maths. Root of 3 at the top times root of 2 becomes root of 6 over root of 2 times root of 2 becomes 2. If you punch this expression in your calculator, it will give you root of 6 over 2. You can try it. Root of 6 over 2. All this without a calculator. So you may be asked to behave like a calculator when you're asked to rationalize a certain situation. Let me do these examples here. Let me try example number 1 very quickly. Example number 1. Let's go for it. 6 over root of 3. No calculator, fam. 6 over root of 3. What should I multiply by? Come on now. I don't want the denominator to have a surd. What do I multiply by? Right? What do I multiply by? I don't want the denominator to have a surd. What do I multiply by? Yes, root of 3 over root of 3. So you're getting rid of the bottom guy. So eventually the answer is 6 root of 3 over 3. I need to 6 times root of 3 is 6 root of 3. Then root of 3 times root of 3 is 3. Then eventually this 3 can cancel out the 6 and your final answer is 2 root of 3. That's number 1. Let's try number 2 together. I want you to try number 2 and tell me what you get. Remember, rationalizing the denominator. I don't want the denominator to have a surd. I don't want it to have a surd. Number 2, 30 seconds. Go for it and type your answer. All right, I think people have gotten it. Same thing like we did with question number 1. Same thing. Before I do number 2, let me go back to number 1 just to make it a bit more clearer. So it's 6 root of 3 and you're asked to rationalize. And I'm saying when rationalizing, you don't want the denominator to have a surd. So why don't you multiply by the very thing, root of 3 over root of 3? Pela root of 3 over root of 3 is just like saying 1. Root of 3 over root of 3. And so you can do the math. 6 times root of 3, 6 root of 3. Root of 3 times root of 3 is 3. Then the 3 will cancel out the 6, and there's a 2 at the top now. It's like saying 3 into 6, and the answer becomes 2 root of 3. If I was to do number 2, I'll do the same thing. 1 over root of 3. I need to multiply by root of 3 over root of 3. 1 times root of 3 is root of 3. Root of 3 times root of 3. The answer is 3. You're multiplying by the very thing right here. Number 3 gets a bit tricky because I want to show you how it's done. Number 3 gets a bit tricky. I want to show you how it's done. Work with me. Let me take this out. Hope you guys got this and are understanding. Let's go for number 3. Number 3 says 5 over 4 minus root of 3. That's what number 3 says. All right. 5 over 4 minus root of 3. You want to get rid. You don't want the bottom guy to have a denominator. But the problem here is that this surd is not alone. There's a 4 in front of it. So then how do we get rid of that? The principle comes from grade 10, as well as a bit of grade 9. Difference of 2 squares. How to get rid of something. You see, when it's like this, multiply both sides by 4 plus root of 3 over 4 plus root of 3. Ooh, say, what you saying, man? Difference of 2 squares. That's what I'm saying. So I know there's a 4 minus, but to get rid of this whole expression at the bottom, need to have a plus. So 4 plus root of 3 over 4 plus root of 3 is like saying times 1. I need to they cancel out. You're manipulating maths. You want to get rid of the surd at the bottom. So if it's an expression like this, if it is an expression like this, 4 minus root of 3, then it means multiply that expression by 4 plus root of 3. Let me show you quickly why I would do that. Let me just do some side notes here. Let me just do a box and show you some side notes. Did you know when you say 4 minus root of 3, then 4 plus root of 3, it's like saying 4 squared minus root of 3 squared. Did you know that? That's what it means. 4 squared minus root of 3 squared. Let me show you where I'm taking it from. Let me show you where I'm taking it from. From grade 9 and 10, if I write to you and say x minus y, then x plus y is as good as saying x squared minus y squared. Difference of 2 squared. I need this minus and this plus to multiply, and eventually I'll get rid of the surd. So in other words, when I say 4 minus root of 3 multiplied by 4 plus root of 3, you can even do it the long way. Let's do it. 4 minus root of 3. Let's FOIL this thing. 4 plus root of 3. We're foiling now. We're foiling. 4 times 4, 16. 4 times positive root of 3 is 4 root of 3 minus root of 3 times 4 minus 4 root of 3 minus root of 3 times root of 3. The answer is minus 3. Eventually, these cancel out. They are the same. And you're left with 16 minus 3, which is 13. The same way here, this will be 16, 4 squared minus 3, which is also 13. So you've got 4 minus root of 3. You want to get rid of the square root sign of the surd, then multiply by 4 plus root of 3. I want you to hear that out, right? Always use the opposite sign. It becomes difference of 2 squares. Always use the opposite sign in an expression like this. It becomes difference of 2 squares. The same way I showed you here, x minus y, opposite sign, x plus y, x squared minus y squared. And then 4 minus root of 3 plus multiplied by 4 plus root of 3, it becomes like that at the end of the day. So always use the opposite sign. All right, let me take this out and then let me redo this question nicely. So 5 over 4 minus root of 3. It's an expression. It's different from this one. This one was easy. There was no 4 in front or any number at the back. It was just root of 3. So it was times root of 3 over root of 3. But this one, multiply by the opposite sign so that it becomes difference of 2 squares. Do the maths. Let me do the bottom guy first so it becomes easy. I've shown you the expression. It's like saying 4 squared at the bottom minus root of 3 squared. Then 5 times 4 plus root of 3. 5 times 4, open the brackets, 20. 5 times root of 3 plus 5 root of 3. That's what I'm getting. Then we can go down to the bottom and get down to business and see if we can win. So now I've got 20 plus 5 root of 3 over 4 squared, 16 minus, there you are, root of 3 squared is 3. And eventually your answer, and there's not much you can do about it, is 20 plus 5 root of 3 all over 13. And that's your final answer right there. So please get that done. That's number 3. Always try, when there's an expression, do it this way. The positive, the negative. Right, go ahead. I'm listening.
So I want to ask, right? So my question is, if we got the same thing, but then the difference is below the denominator was squared, what are we supposed to do? Are we going to double it and then FOIL and then solve for it normally like we did in the previous one?
So you're saying the denominator here is what? Give me an expression.
So, okay, it's 5 over 4.
The 5 at the top like this. 5 over
is
4
minus root 3, and then you square it.
Like this.
Put it into brackets.
Like this.
Wait, let me see.
Okay, maybe, or just write down what you're talking about, then I can get to understand where this is coming from. But the point is, just to reiterate, guys, when there's a minus and it's an expression, put the same expression but with the plus, because that way you'd have created and manipulated maths and made a difference of 2 squares. All right. Let me talk about the last one there, number 4. Then we go to surd equations. Very important that you understand this, number 4. Then we can go to the surd equations. Number 4 is interesting because it's not, you see, the whole time it was like this. We did a 3 and we just said, yeah, to get rid, just say root of 3 over root of 3. That's what we did. But this time there's an 8 over a cube root of 2. That's 3 expressions. That's cube root of 2. You see, here, the ghost was 2. So we had only 2 expressions, 1, 2. But now the ghost is 3. We can't have just 2 expressions. It's 3. All right? In order for me to completely get rid of this cube root, I must multiply 3 times. I will say root of 2 over root of 2. I will say root of 2 over root of 2. So it's not enough to multiply twice. It won't get rid of the cube. Remember, I don't want to have a denominator as a surd. I don't. So when I said 3, it's 3 times. 3 expressions. 1, 2, 3. Root of 2 over root of 2 is like saying 1. Root of 2 over root of 2 is saying 1. So it's like times 1. It's the same thing. But the key to understanding was making sure that we should get rid of the cubed by multiplying 1, 2, 3. So that the cubed goes. If it was squared, 2 times was enough. But now it's cubed. 3 times would suffice. All right? So that's very important that you get this right. It says 3 cube root of 2. And if you multiply cube root of 2 times 2 times 2, right there, at the end of the day, you are going to end up with a situation whereby, so it's supposed to be like this. So don't forget the ghost. I'd forgotten the ghost. Don't forget the ghost there. So that it multiplies itself 3 times. And the ghost will vanish. Don't forget the ghost. The ghost right there. They will vanish. So it's cube root 3, cube root of 2 over cube root of 2 times another cube root of 2 over cube root of 2. These cube roots are as good as multiplying by 1. You want to make sure you get rid of that particular base or that particular denominator, which has a cube root of 3. So you multiply 3 times 1, 2, 3. There's a 3 there. All right. You see, when it was the silent 2, you just multiply it twice. 1, 2. When it was just square root. But now it's cube root. Multiply everything by the cube roots. Work with me. Work with me. I'm at the top here. So I've got 8 times cube root 2 times another cube root 2. All right. It's as good as saying cube root of 4 over at the bottom, cube root of 2 times cube root of 2 times cube root of 2. The answer becomes 2. That's what I wanted. I wanted the bottom, the denominator, to have a 2 or a number which is not a surd. But because it was cube, I needed to have it 3 times. And now the number at the bottom, the denominator is a 2. And then now you can do the last step, which is 2 into 8. And then the answer becomes a good 4. So now it's 4 cube root of 4 as your final answer. Let me go through this one more time. One more time. Listen to me carefully. I'm taking this out, starting from scratch. So it's 8 over, you write a nice over cube root of 2. That's what it is. 8 over cube root of 2. And Use says multiply this by 3 expressions. Times 1, but then to make our lives easy, because it's cube root 2, that's my denominator. Everything cube root 2, I need 3 expressions. Cube root 2, I need 3 expressions right there. Cube root 2. And Use is saying this cube root of 2, if you multiply it 3 times, it eventually gives you 2. The square root would need you to multiply twice. It will give you a whole number, the cube root 3 times. Then I've got the 8 at the top. Then cube root 2 times cube root 2 is like saying cube root of 4. I need to 2 times 2. And then the 2 cancels the 8. Now I'm left with 4. Then cube root of 4. That eventually becomes your answer at the end of the day. Let me attend to some of the questions here. Go ahead. We are winning. Surds equations up next, and we are pulling through from there. I'm listening. Go ahead.
Hello, sir.
Hi.
So sir, when we did, there was a question that we did. I think it was B. You said that if the square roots are the same and they're multiplying each other, then the ghosts lose each other, then the square roots lose each other, then the number becomes 1. So I'm lost here, sir, when we have a result of um 3 square root 4, 4 cubed, because you said that um the square roots they lose each other.
Yeah, I said when it's square root. Is the difference between writing something like this, writing something like this. These are 2 different things. When I say this to
Is
you,
it because of the ghost?
yes, the ghost. If the ghost is a 2, then definitely it vanishes, right? If the ghost is a 2.
Okay.
But if I say this like this, then eventually I have this part. Do you see that?
Okay.
Yes. So
Yes,
only
sir.
if the ghost is a 2. Thank you for that one.
Okay.
Perfect. For
Thank
it
you.
to vanish, you must multiply it 3 times. If the ghost is a 3, for it to vanish, it must be multiplied 3 times.
Yes, sir.
All right, perfect. All right, go ahead. Someone else has a hand. I'm listening.
Yes, sir. I had the same question. Could you perhaps explain the concept behind the vanishing of the square roots?
Okay.
Maybe can, yeah.
There's a video of mine on YouTube, exponents, right? So when you say root of something, root of 2 in maths, it's like saying 2 to the power half. That's what root of anything means. So when you say, let me take this out, right? When you say then root of 2 times root of 2, it's like 2 to the power half multiplied by 2 to the power half. The laws of exponents say the bases are the same. That's 2. Add the powers. Half plus half is 1, right? 2 to the power 1 is 2. That's why your answer eventually becomes 2. That's what you do. So in that aspect, that's where it comes in. So when it comes to the square root sign, when you multiply it twice, it eventually changes, and you will get your final answer as equal to the very number that you're multiplying. Go ahead. I'm ready for my next part, surd equations. Go ahead.
So could you please explain that concept, but in terms of cube roots? Why can't they cancel out? And why does it have to be 3 of them in order for them to cancel out?
Square root means goes to 2. I need 2 things to come together to give me the same number. Cube root means goes to 3. I need 3 things to come together to get me the very number. You see that? Also, so when it comes to a square root, the square root, we only need 2 things. But for the cube root, 3, you need 3. That's the concept that is being established here. For square root, you need to multiply twice to get the number, to get rid of the square root sign. For the cube roots, you need to multiply 3 times to get rid of the cube root sign. That's very important. Cube root 3 times, square root 2 times. And I think I'm being clear on that one there, and we take it up. If it was 4 root 4 times, 5 root 5 times, you get the idea in all of that. Okay, perfect. Thank you for the questions, guys. Let's go to third equations. Very important. They are examined in grade 12 as well. There'll be about 5 marks, 6 marks in grade 12. Eyes on the board. Let's work it out together and see what we can do. Follow my lead. When you speak about a third equation, is something like this. It's a third equation because there is a variable x under a square root sign. All this time, we've just been dealing with numbers under a square root sign. Now we want to deal with variables, unknowns under a square root sign. So you could find a question that says, solve for x. So you've got the square root of x minus 4, then minus 5 is outside. When solving equations with surds, it's important to follow these rules. Number 1, make sure that the expression with the square root sign remains on its own. Angithi there's root of x minus 4, ne? Minus 5. Take the minus 5 to the other side. And this root of x minus 4 remains on the left-hand side on its own. Make sure the expression with the variable always is on its own. The square root sign is on one side of the equation. And why do you do that? It's because to get rid of the square root sign, you must square both sides. My third thing says square both sides of the equation to get rid of the square root sign. So anytime in mathematics, to get rid of the square root sign, what do? Square both sides. Square both sides. That's how you get rid of the square root sign. All right, say, all right, go deeper, go deeper. All right, then work with me. Square root of x minus 4 squared. I've gotten rid of the square root sign by squaring both sides. Now I've got x minus 4. 5 squared is 25. Then I can transpose. That means x is 29. That's simple. Make sure that the square root expression is on its own. Square both sides, then solve for x. It's easier when you think about it this way. They want you, once you get your answer, put it back and see if it makes sense. Try to do this in the calculator. I need to say x is 29. Go for it. 29 minus 4, then outside minus 5. What answer do you get? Let's confirm the answer. You see, this says you must check. Check by substituting into the original equation. Check. What do you get? Is it 0? Is it 0? Yes, it's 0 right there. So at the end of the day, you're going to substitute back into the original and you get your answer as 0. It confirms your answer that x as 29 is the true value for this particular expression. So again, just as a reiteration, a third equation is an equation where the variable of x or the unknown is under a square root sign. How do you then solve it? Take or make sure that the expression with the square root sign is on its own. I've taken -5 to the other side. Then what do? Get rid of the square root sign. How do I get rid of the square root sign? Square both sides. I've squared this side. I've squared that side. I eventually have x minus 4. It's the same thing. If I say the root of 2 squared, I need the answer would be 2. If I say the root of x squared, I need the answer would be x. If I say the root of x minus 4 squared, the answer would be x minus 4. To get rid of the square root sign, square both sides. Then once you get your answer, you can then confirm and take it back into the original to see if it works. Just as a reiteration, just to note a couple of things, work with me, just to note a couple of things. And by the way, you do get a mark for checking. There's a mark for checking. You'll see when I do the ones where there is quadratic equations, you get a mark for checking. You always get a mark for checking. So if the question is out of 6, the 6th mark is checking. All right, perfect. Just as a heads up again, fam, listen to me. If x is greater than or equal to 0, like here, then the expression root of x will be a real number. Makes sense. I mean, if x is greater than or equal to 0, then the answer will be a real number. But if x is less than 0, if x is negative, imagine putting a negative under a square root sign. Your eventual answer is non-real. Try it. Try saying root of negative 6. It will give you an error. So when dealing with the validity of numbers, you put them back into the original. But I want you to remember this. If x is greater than or equal to 0, the expression will be a real number. Like our root of 16, these are numbers. These are greater than or equal to 0 numbers. They are all going to give you a real number. As long as the number under the square root is positive, is greater than or equal to 0, your answer will be a real number. If it is less than 0, if the number under the square root, if the x is less than 0, is negative, the answer will be non-real. It will definitely be an error if you put this in the calculator. You'll see this last part, very important. If a particular solution, let's say you find two values for x is 29, let's say, and x is 4. If a particular solution, you need to put it back into the original. If a particular solution does not satisfy the original equation, it is not a solution. It's not. Let's say you put it into the original and x is equal to 4, does not give you the 0 that you wanted. Then this is not the solution. The solution only becomes x is equal to 29. That's very important. One more time so I can help you. People are saying they are lost. Where are you lost? Let me know what the problem is so I can find you. Talk to me. What is the problem? Lift up your hand. Let me know what the problem is. I'm just showing you the basics of how you actually can solve for a third equation right there. All right. Let me go to a couple of questions here. Maybe through the questions, you can see what I'm going to do. This is a practice exercise. I want to run through it and work on it together with you. So in this exercise, they are simple saying, solve for x. Solve for x. That's what I'm going to do. So I'm going to use these questions as examples of what you can do when you're solving for x. Number 1 says to me, root of x minus 3 is equal to 2. This is a third equation. And what do we do first? Let us get rid of the square root sign. How do you get rid of the square root sign? You square both sides. So in other words, root of x minus 3 squared is equal to 2 squared. Don't forget to square both sides. Root of x minus 3 squared eventually becomes x minus 3. It becomes what's inside here is equal to 2 squared, which is 4. The rest is maths. That means x is equal to 7. Now you can check this. You can check this in the calculator by going back to the original equation. And so in the original equation, where there's x, just put 7. 7 minus 3, the answer becomes 2. Root of 7 minus 3 becomes 2. Then that's where it comes from. So that's very important to understand. Get that right there. So that's number 1. I think we've done that. We've checked. Write this down. Let me try number 2. It's more interesting. Number 2 is more interesting. Work with me. We want to make sure we win on this one. Number 2, let's go for that. Taking this out. Gone. Gone. Going. Perfect. Number 2 says root of negative x negative 1 is equal to x plus 1. Okay, all right. Use says you need to make sure that the expression with the square root sign is on its own, and luckily for us here, it's on its own. We need to get rid of the square root sign. So let's square both sides. Root of negative x minus 1 squared is equal to x plus 1 squared. You square the left-hand side, you square the right-hand side to get rid of the square root sign. Then once you are here, this becomes negative x negative 1 is equal to, here you need to open up the brackets, x plus 1, need to FOIL this thing, x plus 1. So then this becomes x squared, eventually plus 2x plus 1, negative x negative 1. Now the expression is a quadratic equation. It is. It's a quadratic equation. And if it's a quadratic equation, you can't solve it unless the value of x, or rather the expression, is equal to 0. So take everything to that side. Eventually it's x squared. Angithi negative x changes to a positive. That becomes positive 3x eventually. And then here this negative 1 changes to a positive. 1 plus 1, it gives you 2. Then you can factorize. You can use the quadratic formula or the simple FOILing method. That's a plus 2. That's a plus 1. Eventually, your answers for x are negative 2, or the value of x is negative 1. All right? That's what you get there at the end of the day. Negative 2, negative 1. But we're not done. Let's go and check them. Let's go and check them in the original to see if this would work in the original. Work with me. Now, people are understanding. Now they are seeing the light. I love it. I love it for you. All right, work with me. Let's try and substitute x as negative 2 here. Let's see. We're now going for the check. Check your surroundings. Root of negative, and it is negative 2 minus 1 should be equal to negative 2 plus 1. Is this true or not? Confirm. I'm checking. Even if this one is negative 1, I'm going to put it back. Which one is true? Top or bottom? Remember the x is negative 1. You just want to confirm. I need to put the x as negative 1 here as negative 1 to see if the left would be equal to the right. Which one is true? Which one is true? The top one or the bottom one? Which one is true? Top or bottom? Top or bottom? The bottom one is true. So this one is not true. So this cannot be the solution. So the only solution is when x is -1. I need you to just put this in the calculator, the left-hand side, get the answer. The right-hand side, get the answer. If the answers are not the same, then definitely that is not the solution. So that's your answer right there. Let's try number 3. Let's try number 3 very quickly. Just want to make sure that you guys are on the right track with me as we work together. Always check. Go ahead. I'm listening.
Sir, do you have to state your restrictions?
Okay. All right. I hear you. No, you don't have to. Once you get the 2 solutions, test them and only pick the one which works.
Okay, thank you, sir.
All right, anytime. All right, let's go for number 3. Thank you for that beautiful question. Let's go for number 3. Number 3. Boom. Try number 3. I'm going to do 3 and 4, then I'll give you guys 5 and 6, just to see if you're on the right track with me. So we're all learning step by step, day by day. Let's do this. So number 3 says root of 3x squared minus root of 12 is equal to 0. Solving for x ne? Yebo lapo. Naso? So listen to this. Remember, Use says the expression with the variable, with the square root, must be on its own. And it must be on its own. So then I think I can take root of 12 to the other side. Negative root of 12 becomes positive root of 12. And what do I need to do? Get rid of the square root sign by squaring both sides. Root of 3x squared root of 12 squared right there. Root of 12 squared is 12. Root of 3x squared is actually 3x squared. You see? Remember, when you root something, the square of the root of something is something. So the square of the root of 3x squared is 3x squared. That's how you get rid of the square root sign. Divide both sides by 3. I get a 4. X squared is 4 square root plus or minus 2. Now listen to me. Listen to me. I know that your calculator will give you 2, but it's x squared, so there must be 2 answers. Plus or minus 2. Plus or minus 2. I want us to test them now. I want us to test them. The answer is x is plus 2. The other one is x is minus 2. Let's check in the original if they work. In other words, this, I'll put -2 first squared minus root of 12. Does it gives you 0? We need to check. Also at the same time, 3, then 2 squared minus root of 12. Does it gives you 0? Do both of them work? Is it the top guy that works or the bottom guy that works, or both of them work? Both are true. So I've checked. Both of them are very true. Very true. All right. Perfect. Let's try number 4. Ooh, number 4. Number 4. Talk to me where there's a problem. Now we are winning. I see that we are winning. I see. We're working it out right there. We're pulling through for that. Batini bona. Bati. Siya winner. We're winning. Number 4. Number 4. Then you guys do number 5 and 6. There's some that I want on number 5 and 6. All right. Others are still writing. Not a problem. So basically, guys, when we start in February, this is how we're going to do things. You know, it's going to be massive. Look at the amount of work that we have done in less than 2 hours. We've done a lot, you know. So we are winning on this one. This is what I'm going to offer you for the February paid classes. Remember, 5 classes per month, 250 rands for each subject. I'm going to be on fire. Maths will be on Mondays for grade 11s and physical sciences on Wednesdays for grade 11s, 7 p.m. to 9 p.m., just like the same way we are doing right now. There's a hand up. Go ahead. I'm all ears.
So about the classes, right?
Mm-hmm.
Is it possible to pay it separately, or like you have to pay it as a package, like for 5 classes? And let's say I want to attend only 3 classes. So should I pay like for those 3 classes, or it's only available for that 5 classes, which is 250?
Okay, I hear you. All right, so for that particular part, it's just a whole package for the whole month. But I will consider your request and I will let you guys know what I've decided for now. But for now, definitely, I just want the package. That means it becomes easier to control and it becomes easier to track the progress. Because if you have a student that's coming in for the whole month, it's easier to track their progress and to be actually very good in teaching them. Someone may come in February, the next thing they come in June, and then they say, but Mr. X didn't teach me, blah, blah, blah. But you were never there for 5 months. You see? So I would rather have people coming in monthly. We know that, you know what? That's where I can assure you, I can get you a distinction. Instead of coming here and there as and when we feel like it. So that's always my advice to students as well as their parents. But I will consider that. I'll let you guys know what I think about that before the end of this particular week. Right. Thank you for that beautiful question. I appreciate. All right, guys, let's try number 4. Try number 4. Right. Let's try number 4. Right. Let's go. Number 4. Number 4 says root of 18. Oh, yeah. Root of 18. Common ground. I hear you. X root of 2. Nazo. Root of 32. Root of 18. Okay, common ground, man. Common ground. Talk to me, common ground. Talk to me, common ground. What can I do? What can I do? There's many things that you can do, many ways of doing this. Can we say minus x root of 2, leave it on its own? Then I say root of 32 minus root of 18. Then root of 32 can be written as 16 times 2. I've seen these numbers before. Root of 18, 9 times 2 minus x root of 2. Then root of 16, that gives you 4, right? So it's 4 root of 2 minus root of 9, 3 root of 2 minus x root of 2. I see what I see on the right-hand side. I see 4 root of 2 minus 3 root of 2. That's root of 2 minus x root of 2. Then I can divide both sides by root of 2. The answer is 1 here minus x. I want to find x divided by negative 1. Your answer becomes x is negative 1. It's the only solution available anyway. It's the only one available. And eventually, if you put it back into the original, it will definitely give you that answer if you'd like to check it. But it's the only solution available right there. The key, again, was making sure that you remember that at the end of the day, your particular game plan is to make sure you have common ground. Let me repeat this very quickly. Follow my lead. So I needed to take the root of 18 to the other side. That's what I did. Root of 18 to the other side. So now I've got negative x root of 2, root of 32 minus root of 18. Then it's 16 times 2 minus 9 times 2. 16 times 2 is 32. I need this 16 so that it can be rooted to become a 4. I need this 9. It can be rooted to become a 3. I've done this before. Now we've got 4 root of 2 minus 3 root of 2. These are like terms. Like saying 4x minus 3x is x. 4 root of 2 minus 3 root of 2 is root of 2. Then divide both sides by root of 2. And when you do that, you get a 1. Negative x is 1, but you want x, not negative x. So divide everything by negative 1. This is your final answer. That's your answer. You guys are up for number 5. You guys are up for number 6. Very quickly, we work it out there. 5 and 6. Did you know that when I say to you, to the power half, this is as good as saying root of x minus 3. Just in case you didn't know, ukuthi to the power half means root of x minus 3, right? So x minus 3 to the power half is root of x minus 3. I want you guys to attend 5 and 6. Let's give you 2 minutes and hang in there for that one. Try number 5 and number 6 right there. All right, people are done. People are done. Let's just confirm this and see if we're on the right track as well. Follow my lead. So we started the first one, which is number 5. We already said this is like root of x minus 3. Every time they say to the power half, don't forget it means root of. Let's square both sides to get rid of the square root sign. And so now This is now 16 x minus 3. So x is 19. I suggest that you check, please. So checking means you put it like this in the calculator and see if it does give you the number 4. And yes, in this case, actually, it does give you the number 4. Very interesting. Let's work it out together and see how far we can go. So that's number 5. Done and dusted. Beautiful. Ooh, number 6. Number 6. Let's see if number 6 works and we take it up. So I'm hoping that you guys got this right and you won on this one. And let's see. Number 6. Gone, going. Beautiful. X squared minus 5 is equal to the root of x squared plus 1. We need to get rid of the square root sign, so we square both sides. X squared plus 1 squared x squared minus 5 squared. Now on the left-hand side, it gets very interesting because I'll end up with x to the power 4. Somehow. This one is still x squared plus 1. Follow my lead. So this becomes x to the power 4, because you say x squared times x squared, x to the power 4 right here, minus 5x squared minus 5x squared plus 25 is equal to x squared plus 1. Then x to the power 4 minus 10x squared. Take everything to the left-hand side, minus x squared, then plus 25. See what I'm doing? I'm transposing because I can't solve this unless everything has been equated to 0. I won't be able to solve. So then now I've got x to the power 4 minus 11x squared plus 24. All this is equal to 0. That's what I get. X to the power 4 minus x squared plus 24 is equal to 0. Right, somebody has a hand. Go ahead before I go further. Just want to make sure that I'm clear with you.
Hello, sir.
Hi.
So about our laws of exponents, we learned that if a power is raised to another power, we can just instead of doing the FOIL method, we can just multiply the powers. So that is what I did, and I got x squared minus 25.
You got x squared minus 25. You said if the
Sorry,
power...
x to the power of 4 minus 25.
No. This is like, remember your foiling is this times this. Then it's this times this. It's a number and an expression. Minus 5x squared. Minus 5x squared. Minus 5 minus 5 is minus 10. It's like this.
So I did not use the FOIL method. I used the laws of exponents. It says when another power is raised to another power, you just multiply the powers, and that is what I did.
But at the bases must be the same for you to do that. You see, for an example, 5 and x squared are not the same base. So you can't just eventually multiply like that. The bases must be the same for you to be able to do that. So for an example, x squared when multiplied by x squared is as good as saying x to the power 4, 2 plus 2. I needed the bases are the same. But when you FOIL, because you need to FOIL, these are brackets, you square both sides. When you FOIL and say x squared times negative 5, it can't be just negative 25x squared or 25x squared. You've got to FOIL it in such a way that eventually it's like this and like that. Is that okay?
I get you, sir.
Perfect.
Yes, thank you so much.
Beautiful. All right, so here we are, guys, and let me just stop here. This is now a problem because we never get to use x to the power 4. 4 How do you even solve it? We're used to x squared, Tina. That's what we do. Where's x to the power 4 coming from? Let me show you. Imagine if it was like this. You could be able to solve it, right? You would put an x there and an x there, knowing that this x and this x will multiply to give you x squared. You'd know that. But what if it's x to the power 4? You know, what if it's x to the power 4? What do I do? Well, same thing. But this time it's x squared, then x squared right there. And remember, when you're now dealing with this situation, you would need to have it as -8. Remember that it must be the numbers that you get must multiply to give you positive 24, but add to give you -11. This is from grade 9. There you are, equal to 0. That means x squared is 8 or x squared is 3. That's what it means. So now let's be clever. Let's be clever. Before we even solve for x, let's see which one works. Let's see which one works. If we were to take 8 in here, x squared is 8. Does it work? If we were to take 3 in here, does it work? I want you to tell me which one works. Is it the x squared is equal to 8 or the x squared is equal to 3? When you substitute it, now you need to check. You need to check. So we're now checking and then see which one works. So 8 squared minus 5 is equal to root of 8. No, it's not 8 squared, it's 8 actually, because x squared is 8. So it's 8 minus 5. X squared is 8. 8 plus 1. Let's try the other one. 3 minus 5. Let's see if it will work. 3 plus 1. Which one works? Is it the x squared is 8 or the x squared is 3? Then once we know which one works, then we can quickly find x. Is it the x squared is 8 or the x squared is 3? I think it's the x squared is 8. So therefore, this one does not work. So the only solution is x squared is 8, and we can square root it. The answer is plus or minus root of 8. So at the end of the day, your answer for this one is plus or minus root of 8. It will be true for that. I want to show you this again. Listen to me. I'm a bit worried about this part. X to the power 4 minus 11x squared plus 24. And I'm saying, imagine it was x squared minus 11x plus 24. You would have just simply said this. Simple. Because you know that x times x will give you x squared. But since it's x to the power 4, I will put x squared, because I know that x squared times x squared will give you x to the power 4. Then I put the other numbers that complete my equation. Minus 8, minus 3, x squared is 8, x squared is 3. Check it. The only one that works is x squared is 8. And then now you can solve for x. If x squared is 8, that means x is plus or minus root of 8 as your final answer in that particular regard. So that's your answer for surd equations. Now, listen up. Guys, this is how you do the maths. So the topic for today was just surds. And in all of this topic, what we're dealing with was the mathematics of numbers that are under a square root sign. We learned about how to deal with them with the laws of surds, the multiplication, the division, the addition, and the subtraction. We learned about rationalizing the denominator, not forgetting that if the ghost is a cube, you multiply by 3 expressions. If it's a squared, twice rather. Then here we just learned about surd equations, how you solve them. Make sure that the expression with the square root sign is on the left-hand side or right-hand side, or rather on its own, so that you can solve it quickly by squaring both sides, and eventually you'll get your answers from there on. Just to show you what else I had prepared for you right there, because our time is really gone, and the rest is just something that I'm going to do in the paid classes. You see, I had past exam papers. Oh, my word. Look at this one here, 2016 November. This one is 2024, the Gauteng paper. This one is 2017. All these crazy, beautiful past exam papers that I had for you, but I'm going to do them in the paid classes. This was just a simple, giving you the basics kind of thing. As we end, don't forget the most important thing, guys. I am going to be doing paid classes, 250, 5 classes per month, starting on the 3rd of February, 2 hours each, just like what we've just done now, from 7 o'clock to 9 o'clock. On Mondays, Maths grade 11. On Wednesdays, Physical Sciences grade 11. So if you want one subject for the month, it's 250 the whole month. If you want 2 subjects, it's 500 rands. My name is Mr. X Kolani. Thank you guys for coming into my class. I hope you guys learned. In my culture, or not just my culture, but in Africa, when someone does something for you, you say thank you. We are bonga. And it's we are bonga. So I hope you guys are thankful and you learned and you understood and you appreciated what happened. Let others know about Mr. X, the things that I can do. I can save them. I can help them just the same way that I am helping you right now. So what I want to do now is I'm going to stop the recording. Then I'm going to unmute all of us here. Then we can have a bit of a chit chat and we can just have fun. Then we can call the day off. Those watching on YouTube, thank you so much. Don't forget to leave a message, question, or if you have one, a comment, anything. Mr. X is always willing to interact with you.